In today's lesson, we're going to take a look at section D8, standard D8, inclined planes. And to discuss inclined planes, first let's establish what I mean by that. And that is any surface that makes an angle with a horizontal. So if you're talking about the horizon or the horizontal, that's any angled surface which gravity would cause an object to want to go down. It is actually gravity, or the weight of an object as it lies upon an inclined plane, that causes it to roll or slide down that surface. And what we're going to look at today is trying to figure out how we can determine the motion of objects on inclines and how gravity is what drives it down there. When we talk about the rate at which an object descends an incline, there's a couple factors that are in play. The angle the surface makes with the horizon is one of the factors. Force of friction acting between the surface and the incline itself sometimes is a factor, other times it's not. And then we have the mass of the object. So these three factors, the angle, the frictional force if present, and the mass of the object, are all the things that determine how an object goes down an incline. The mass of the object is important because that's what determines the weight of the object. And the weight of the object is its force of gravity. Now, we talked about those three factors, but there's at least two forces that are always going to be acting on an object, on an incline. The first one is going to be the force of gravity, right? And then the second one is going to be the normal force. Those two forces are at the bare minimum. The frictional force, which is what we talked about earlier, sometimes that's in play, other times it is not. When we talk about inclined planes, the coordinate system for the inclined planes, you always have to adjust your axes either perpendicular or parallel to the surface of the incline. Objects are always going to have their acceleration and their net force being parallel to the inclined plane. So when we talk about all the forces acting on it, we need them perpendicular or parallel to this incline. The force of gravity, unfortunately, is not oriented either parallel or perpendicular to the incline of the plane. It's somewhere in between the two. So our first and most important aspect whenever looking at inclined planes is trying to take this force of gravity and resolve it into its parallel and perpendicular components. So here we have some diagrams that are showing the force of gravity. The left-hand one is showing force of gravity by itself in black, pointing directly down. And you can see from the incline that force of gravity is not oriented either parallel or perpendicular to the incline. Over on the right, you can see that I've split the gravity into two components. One component that is parallel to the incline, and the other component which is perpendicular to the incline. Once we resolve these two components into their respective, these gravitational forces into their respective components, we can then do more analysis on the motion of an incline. Now, if we're talking about the two components of the incline, the force applied down the incline is always going to be equal to the magnitude of the parallel component. So if you take gravitational force and you find the parallel component of gravitational force, that's what's going to be directed down the incline. If there's any friction in this problem, or say the object's stationary on the incline, that parallel force is going to be what's equal to the frictional force. The other component we're going to look at for gravity is going to be the perpendicular component of gravity to the incline. This perpendicular component is going to be what's pointing directly into the incline, and the normal force, if we were to calculate normal force, is always going to be equal to the perpendicular component. So let's go ahead and do an example for this. If we have a 5-kilogram box that rests on an incline, which makes an angle with the horizon of 15 degrees, we want to know what the parallel and perpendicular components of this force of gravity acting on the box are. So we have to do a couple things here. First, we have to find the weight of the box in newtons. To do that, we're just going to take the mass of the box and multiply it by 9.81. Once we have the weight, we're going to split that force of gravity into two components. Now, I've drawn a diagram here, and you can see that in the upper part of the diagram, I've just represented the incline, the angle, and the box sitting on it. Down below, I've taken this force of gravity that's acting on the box, and I've split it into two components. Force of gravity perpendicular, and you can see that symbol by the two lines that are perpendicular to each other. And then you have the force of gravity that's parallel, and you can see that by the two lines that are parallel to one another. We're going to determine what each one of these are, and then we can identify what the components are. You'll notice that I've drawn a vector diagram where I've resolved that force of gravity into two perpendicular components. The angle that an incline makes with the horizontal is the same angle you're going to see at the top of this vector diagram. So when we're trying to calculate the force of gravity parallel and perpendicular, we can use our sine and cosine functions. There's really actually an easy way to sort of remember this, mnemonic that you can use to recall this. The force of gravity that is parallel to an incline is always going to be the sine of the theta. So you can have the mnemonic, sine makes you slide. So if you're ever trying to figure out what makes you slide down the hill, it's going to be the sine theta times the force of gravity. So let's go ahead and look at solving this problem. First, we're going to find what the force of gravity is. And to do that, we're going to take the mass of the object multiplied by acceleration due to gravity. So it's a 5 kilogram object multiplied by 9.81. And we end up getting a force of gravity of 49 newtons. Now that we know what the weight of the object is, the force of gravity of the object being 49 newtons, now we can go and try to find what the components are. First, let's find the perpendicular component. This is what's pushing into the hill, and it's also what the normal force is going to be equivalent to. Now, if you're looking at our vector diagram over on the left, you see that the force of gravity perpendicular is adjacent to the angle. So force of gravity is going to be the cosine theta times your force of gravity. So cosine 15 times 49 newtons gives us a force of gravity perpendicular to the hill of 47.3 newtons. So that's how much gravity is pushing directly into the hill. This, if we were determining normal force, would also be equivalent to the normal force. So let's look at this second part. We're going to find the other component, this time parallel to the hill. And here we have the same force of gravity, 49 newtons. We're starting at the same spot. But now we want to find what the parallel component is. So here we have that saying, sine makes you slide, right? So the sine of the angle is going to be what's determining the force of gravity that's parallel or making you slide down the hill. So it's sine theta times your force of gravity. That would be sine of 15 degrees multiplied by 49 degrees. And we find that we have a 12.6 Newton force that's pushing us down the incline. So sine does make us slide. Now, if this object was stationary, say there was a frictional force acting on this object, in that scenario, our frictional force, if it's stationary, would be 12.6 newtons.